Hello everyone, I am Fabio Petroni from Facebook AI Research, and in this talk I will present how context affects language models' factual predictions, a joint work between Facebook AI Research and NLP Lab at UCL. At EMNLP last year, in this paper, we show that language models are able to store and retrieve factual knowledge to some extent. And we created the Llama probe to do this kind of analysis, that is a collection of cloze-style questions with a single token answer. And here you can see an example. The theory of relativity was developed by Musk. And we asked BERT to fill the mask, and in this particular case, it predicts Einstein, that is a correct prediction. But storing factual knowledge in a fixed number of weights has clearly limitations. So for this other example, Giacomo Tedesco plays in Musk position, BERT gets it wrong. Also, as humans, we don't always have the answer in our memory, in our parameters, but we heavily rely on external knowledge, for instance, from Wikipedia. So we can go in Wikipedia, look at the Giacomo Tedesco Wikipedia page, and see that he is a midfielder. The idea of this paper is to integrate additional contextual information into BERT in order to study its behavior. In particular, we consider 4 types of contexts: oracle, retrieved, generated, and adversarial. For oracle context, we use the one provided in Llama, that often contains the true answer. For retrieved context, we use the information retrieval system of Dr. QA to retrieve relevant information for the question. And as generated context, we use the generation of an autoregressive language model, and this allows us to test the performance of a solution completely based on knowledge inside the parameters of a neural model. But note that the generation might not be related to the question and also might not be factual. Finally, we test the performance of BERT against adversarial context by randomly sampling oracle context from different questions that has the same relation. And note that adversarial context always contains a distracting and semantically plausible answer. Let me show you some results. In this table you can see the precision at 1 for BERT, that is the percentage of time it gets the answer correct, for the Google RE, T-Rex and Squad datasets in Llama. And when we consider oracle context in input together with the question, we have a dramatic improvement in performance for BERT on the Llama probe. And this result shows the unsupervised machine reading capabilities of pre-trained language models that are able to copy the answer from the context into the masked position. Moreover, when we consider the performance of BERT plus an information retrieval system, we observe that it basically matched the performance of a supervised baseline. In this particular case, we use Dr. QA by translating each cloze-style question into a natural questions. And this is, let's say, really impressive, given that BERT didn't get any supervision at all for this task. When we consider the generated context, we have a slightly drop in performance, while when we consider adversarial context, the performance are more or less the same with no context or adversarial context. And these results really surprised us at the beginning, and we were not sure why this was the case, or why BERT didn't get confused at all by adversarial context. But then we looked into the next sentence prediction pre-training task of BERT, and we found the answer. So BERT was trained both with masked language model, but also to understand if the second segment is a valid continuation of the first segment. So in this particular case, we mapped the question as the first segment and the context as the second segment. So we noticed that if the context is relevant, the next sentence prediction classifier always outputs a 1, and the BERT looks at the context in order to do its prediction. But when the context is not relevant, for instance, as in the case of the adversarial context, we have that the next sentence prediction classifier predicts a 0, and BERT does not look at that context. So it's affected by the next sentence prediction output, and the prediction in this case is equivalent to the 0 context prediction. In this plot, you can see the change in precision at 1 relative to the 0 context. And for BERT, using a single segment or 2 segments, so enabling the next sentence prediction ability. And also for Roberta, note that Roberta has been trained without the next sentence prediction feature, but it has the option to divide the input in 2 sentences by using a end of sentence token. And from this bar plot, you can see that the best performance both in the adversarial case and the oracle case are achieved by using 2 segments, so with the next sentence prediction task. And by using a single segment, the adversarial context completely ruins the performance. And for Roberto, we have a similar behavior, but is not as robust as BERT. Moreover, we notice that the more relevant that BERT thinks the context is, the more we see an increase in the likelihood of the true answer. So BERT heavily relies on the next sentence prediction to actually decide to attend or not over the other piece, over the other segment, to do a prediction in a segment. This table shows the percentage of time that BERT changes its output for the better or the worst. You can see, for instance, that when using oracle context, it changed prediction 34% of the time for the better, and 7% of the time when the context is generated by a language model. So this shows that autoregressive language model can actually generate relevant context sometimes, and potentially serve as unsupervised information retrieval systems. However, BERT is completely unable to filter generated irrelevant or factually wrong information, because he always thinks that the generation is a plausible continuation of the question. So here you can see an example. So for the same example as before, the generated context was how much does he play? He can play fullback, wing, or center. He can also play, and the next sentence prediction score is 1. For this reason, BERT copies the wrong answer from the context, that is fullback. Here is a final example for a retrieved context. And it's quite interesting because even though the answer is not in the context, BERT was able to combine this retrieved information with its own internal representation of knowledge to come out with the correct answer. To conclude, I think we should reconsider the next sentence prediction task, because we show that it is an important component for robust exploitation of retrieved context. I also want to point out that the comparison with Dr. QA is not 100% fair, because Dr. QA is an extractive solution while BERT is an abstractive, and also the single token limitation of the llama probe is an advantage for BERT. Nevertheless, this work, together with a large body of literature in recent years, show that flexible and powerful unsupervised QA systems might not be too far on the horizon. Thank you everyone for your attention. If you want to follow our works and updates, you can follow me on Twitter, or you can follow any other among the authors. Thank you.